Hello students, today's class video was not very good, so I decided to make a video of my own regarding the same topic. So let's begin with the redox reaction. What we have learned earlier is an electrovalent bond. An electrovalent bond is basically a transfer of electrons. An electrovalent bond is a transfer of electrons. Okay, so one atom will donate electrons and the other atom will gain electrons. Let's take an example of sodium chloride. Na plus Cl will give us NaCl, which will be Na plus and Cl minus. Now, if you see, the reactants are sodium atom and chlorine atom. Sodium atom, after the reaction, will become Na plus and it will donate one electron. So it will release one electron. Now again, loss of electron is known as oxidation. So we can say sodium atom is going through oxidation. On the other hand, chlorine atom will gain those electrons and become Cl minus. So again, for chlorine, there is a gain of electron, and gain of electron we call it as reduction. So when sodium reacts with chlorine to form common salt NaCl, sodium atom is getting oxidized and chlorine atom is getting reduced. Similarly, let's take another example of Fe2O3. Let me just write the equation. Fe2O3 plus Al will give us Fe plus Al2O3. Now, I'm not balancing the equation because that is not necessary. That is not the point over here. We need to figure out what is getting oxidized and what is getting reduced. Now, if you see in reactant, we have Fe2O3. Fe2, sorry, let me just write it again. When we have a substance Fe2O3, that means this is a positive ion of iron and a negative ion of oxygen, which are combined together, and they react with an atom of aluminum to give us an atom of iron plus Al2O3, where Al will become 3 plus and O will become 2 minus. So let's look at the elements before the reaction and after the reaction. First of all, let's look at Fe. Fe was iron, ion of iron, positive ion. Fe3 plus will gain 3 electrons and it will become Fe. So ions are becoming atom. Now again, there is a gain of electrons, so we call it as reduction. On the other hand, if you look at aluminum, aluminum before the reaction is an atom. So aluminum will lose 3 electrons and become Al3 plus. So if you think about it, aluminum is losing 3 electrons and loss of 3 electrons is considered as oxidation. So again, this reaction is also considered as a redox reaction because Fe3 plus, which is the iron cations, are getting reduced and aluminum atom is getting oxidized. So every reaction, in which there is an oxidation and reduction happening together, we call those kind of reactions as redox reaction. That finishes our first section of the chapter. So now let's start with the second section of the chapter, in which we will be talking about a covalent bond. First of all, what is a covalent bond? The chemical bond that is formed between two combining atoms by mutual sharing of one or more pairs of electron is called a covalent bond. And the compounds formed due to this bond is a covalent compound. So let's see what it means. Atoms of non-metals usually have 5, 6 or 7 electrons in their outermost orbit. Okay, so we already know that non-metals will have 5, 6 or 7 electrons in their outermost orbit. Only exceptions are carbon and hydrogen. Okay, carbon has 4 electrons in its outermost orbit and hydrogen has 1 electron in its outermost orbit. Now these non-metals, they cannot donate electrons. Okay, non-metals cannot donate electrons. So whenever non-metals are reacting with each other, there is no transfer of electron, but actually there is a sharing of electron. And those kind of bonds are called covalent bonds. Now let's do it by an example. The most important part about non-metal, let's say for example hydrogen. Now this is one atom of hydrogen. Again, hydrogen only has 1 electron in its outermost orbit, so it is not stable. It does not have its duplet state. So this hydrogen atom can combine with one more hydrogen atom. It can combine with one more hydrogen atom and become a molecule of hydrogen. Now make sure we understand this. Hydrogen atoms are not stable because they do not have 2 electrons in their outermost orbit. But hydrogen molecule is stable because it has 2 electrons in its outermost orbit. Now if you think about it, hydrogen is a non-metal, this hydrogen is also a non-metal. They are both same, exactly same atoms. When they react together, this hydrogen cannot donate electrons and this hydrogen cannot donate electrons. So there is a sharing of electron, and the bond formed between these two atoms is known as a covalent bond. Let's take one more example. Let's say, for example, hydrogen reacts with chlorine to form HCl. Now, hydrogen has 1 electron in its outermost orbit. Chlorine has 7 electrons in the outermost orbit. So, chlorine will try to gain 1 electron and hydrogen will try to gain 1 electron. Both of these these are non-metals, so they do not donate electrons. So, there will be a sharing of electrons. Okay, so let's see how this bond is formed. Hydrogen has 1 electron in its outermost orbit. It will combine with 1 atom of chlorine. Now, chlorine has 7 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6, and 7 electrons. Okay, so now hydrogen and chlorine are sharing 1 pair of electrons. So if you think about it now, hydrogen, if you just look at hydrogen, hydrogen has 2 electrons, 1 electron of its own and 1 electron from chlorine. So hydrogen atom is stable. Similarly, if you look at chlorine atom over here, chlorine atom is sharing 1 pair of electron. Again, chlorine has 7 electrons of its own and 1 electron from hydrogen. So chlorine also has 8 electrons in its outermost orbit. So chlorine is also stable. And the bond formed between them is known as a covalent bond. Now the way we represent this is by putting a dash between the atoms. That means we write it like this: hydrogen dash and chlorine. This hyphen over here basically tells us that there is a sharing of 1 pair of electron between hydrogen and chlorine. Now make sure we understand this. There is a sharing of 1 pair. That means they are sharing 2 electrons. Okay, they are sharing 2 electrons. And in a covalent bond, it is very important to understand that both the atoms will share same number of electrons. If hydrogen is sharing one electron, chlorine will also share one electron. This has to be equal. It will never happen that hydrogen can share more electrons and chlorine will share less electrons. In a covalent compound or in a covalent bond, the shared electrons are exactly same between the two elements. Okay, now let's go through a few examples just to understand what is a covalent compound in a little more detail, and we'll see what are the different kinds of a covalent bond also. Let's take an example of chlorine. Now, if you take an atom of chlorine, chlorine has 7 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6, and 7. Again, this chlorine atom is not stable. In order to become stable, chlorine needs to have 8 electrons in its outermost orbit. So chlorine, being a non-metal, can combine with another atom of chlorine, which will also have 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. Now both the chlorine atoms are sharing one electron. So again, if you look at this chlorine has 7 electrons of its own and 1 electron from the neighboring chlorine. At the same time, if you look at the other chlorine, this chlorine also has 8 electrons, 7 electrons of its own and 1 electron from the other chlorine. So both the chlorine atoms become stable and they form a molecule which is Cl2. Now again, they are sharing one pair of electrons, so we can draw it like this. This is one atom of chlorine sharing a single pair of electron with another chlorine. Now, when they are sharing one pair of electron like this, we call it as a single covalent bond. Okay, so this is an example of single covalent bond. Let's take another example of oxygen. Oxygen has atomic number 8. So oxygen has 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, and 6. Now again, this oxygen atom is not stable. It needs to have 8 electrons in its outermost orbit. So this oxygen will combine with one more atom of oxygen, which also has 6 electrons. 1, 2, 3, 4, 5, and 6. Now these two oxygen atoms are sharing 2 pairs of electrons. So if you look at it, this atom has 6 electrons of its own and 2 electrons from the other atom, so it has 8 electrons. At the same time, this atom, other atom, also has 8 electrons in its outermost orbit, 6 of its own and 2 electrons from this blue oxygen. So we say that they both have become stable and it forms a molecule of oxygen. Now the way we can draw this is by putting oxygen atoms and we put 2 hyphens over here. This means that these 2 atoms are sharing 2 pairs of electrons. And when atoms are sharing 2 pairs of electrons, we call it as a double covalent bond. Remember, chlorine was sharing 1 pair of electrons, so it was a single covalent bond. Oxygen is sharing 2 pairs of electrons, so it becomes a double covalent bond. Similarly, let's look at nitrogen. Nitrogen atomic number is 7, so nitrogen has 5 electrons. 1, 2, 3, 4, and 5 electrons in its outermost orbit. Now again, this nitrogen atom is not stable. In order to become stable, it needs to have 8 electrons. So this nitrogen will combine with one more nitrogen atom, which also has 1, 2, 3, 4, and 5 electrons in its outermost orbit. Now these 2 nitrogen atoms will share 3 pairs of electrons. You can see this in the middle over here. So if you look at this first chlorine over here, first nitrogen, it had 5 electrons of its own and it is sharing 3 electrons with the other atom. So it has in total 8 electrons. At the same time, if you look at the second nitrogen atom, it also has 8 electrons now. 5 electrons of its own and sharing 3 electrons with the other atom of nitrogen. So after combining, it becomes a molecule of nitrogen. Now this molecule of nitrogen is stable because both the atoms have 8 electrons in their outermost orbit. So the way we draw this is nitrogen and nitrogen. They are sharing 3 pairs of electrons. So we draw 3 hyphens over here. This is known as a triple covalent bond. So chlorine and chlorine is an example of a single covalent bond. Oxygen and oxygen is an example of double covalent bond. They are sharing 2 pairs of electrons. So total they are sharing 4 electrons. And nitrogen, which is N2, is an example of a triple covalent bond. So covalent bonds can be a single covalent bond, double covalent bond, or a triple covalent bond. Now let's try to draw some more examples to understand much better what is a single covalent bond and a double and a triple covalent bond. Let's take an example of ammonia. Ammonia is NH3. Now nitrogen has 5 electrons, 1, 2, 3, 4, and 5 electrons in its outermost orbit. Nitrogen wants to become stable, it needs to have 8 electrons in its outermost orbit. So nitrogen will combine with 3 hydrogen atoms. Now if you look at it, all the hydrogen atoms, have 2 electrons. This hydrogen also has 2 electrons. This hydrogen also has 2 electrons, 1 electron of its own and 1 electron from the nitrogen. So all the 3 hydrogen atoms are stable. Similarly, if you look at nitrogen, which is in the center over here, nitrogen has 5 electrons of its own and 1 electron sharing from the 3 atoms of hydrogen. So nitrogen also has 8 electrons. So nitrogen atom is also stable. So the way we draw this is nitrogen, single bond with 1 hydrogen, single bond with another hydrogen, and a single bond with the third hydrogen. Now this is not a triple covalent bond. Make sure we understand this. This is not a triple covalent bond. This is 3 single covalent bonds. Make sure we understand this. This is not a triple covalent bond because all the bonds over here, nitrogen and hydrogen, is a single pair. They're only sharing 1 pair of electron. Here also they're sharing 1 pair of electron. Here also they're sharing 1 pair of electron. So we call it as 3 single covalent bonds. Let's move further and look at some more examples. Let's look at an example of CCl4. That means 1 carbon atom. Remember, 1 carbon has atomic number 6. So it has 4 electrons in its outermost orbit. Now in order to become stable, carbon needs to have 8 electrons in its outermost orbit. So what carbon does is that it will combine with 4 chlorine atoms. So let's say 1 Cl, which will have 1, 2, 3, 4, 5, 6, and 7 electrons in the outermost orbit. Here it will combine with 1 more chlorine, 1, 2, 3, 4, 5, 6, and 7. Here it will combine with 1 more chlorine, 1, 2, 3, 4, 5, 6, and 7. Remember, 7 electrons for chlorine. Similarly, here 1 more chlorine, which will be Cl, 1, 2, 3, 4, 5, 6, and 7. Now, if you look at it, all the chlorine atoms are stable. They have 8 electrons. First chlorine has 7 and 1 from the carbon. Second chlorine has 7, 1 from the carbon. third chlorine has 7, 1 from the carbon, and the fourth chlorine has 7 plus 1 from the carbon. At the same time, carbon also has 8 electrons, 4 electrons of its own, and one sharing electron with 4 chlorine atoms. So carbon atom is also stable and chlorine atoms are also stable, and it becomes a new substance or a compound. We call it as CCl4. We can draw it in this manner over here: 1 carbon, 1 chlorine, 1 chlorine, 1 chlorine, 1 chlorine. Now remember, this is not a tetra-covalent bond. This is 4 single covalent bond. So don't get confused. What is a tetra-covalent bond? Tetra-covalent bond can be something which is sharing 4 pairs of electrons. But this is not that. This is 4 single covalent bonds. Let's take one more example over here just to make sure we understand everything very clearly about covalent compounds. Okay. Let's say we have C2H2. Now we can draw the hydrogens anywhere, doesn't matter. Now if you see, the molecular formula is number of carbon is C. There are 2 atoms, so C2 and H4. We'll study more about this in last chapter, which is the organic chemistry. So now if you can see over here, there are 2 things. There is a double bond between the carbon atoms, and there are 4 single bonds also. So this is also possible. You can have a single bond, double bond, triple bond, everything combined in one molecule also. This is one molecule. Okay, so now let's see how this works. First carbon has 4 electrons, 1, 2, 3, and 4 electrons of its own. Second carbon also has 4, 1, 2, 3, and 4. Now, if you can see these 2 electrons, first 2 carbons are sharing 2 pairs of electrons, so they are sharing these 2 pairs of electrons. Now, if you count the number of electrons, carbon has 1, 2, 3, 4 of its own, and 2 from the other carbon, so 6. And this carbon also has 6 electrons. Again, carbon needs to have 8 electrons. So it will combine with one hydrogen atom and it will combine with one more hydrogen atom. So now carbon has 8 electrons in its outermost orbit. 1, 2, 3, 4 khud ka, 5, 6 from the other carbon, 7 and 8 from the hydrogen. So now this carbon is stable. Hydrogen has 2 electrons, so hydrogen is also stable. This hydrogen has 2 electrons, so this hydrogen is also stable. Similarly, the other carbon will also combine with 2 hydrogens. And now this carbon also has 8 electrons, just like this. So everything has a stable electronic configuration. Carbons have their octet state and hydrogens have their duplet state. So we can say that this molecule is stable. Now again, there is a combination. There is a double covalent bond between the carbon-carbon atoms, and there is a single covalent bond between the hydrogen atoms. Similarly, you can also have this. This means carbon has 1, 2, 3, 4. Now remember, 4 electrons in its outermost orbit. The other carbon also has 4, 1, 2, 3, and 4 electrons in its outermost orbit. It combines with one hydrogen atom on either sides. So now if you look at the carbon atom, the first carbon atom is this. This carbon atom has 4 of its own electrons, 3 from the other carbon, so 4 plus 3 7, 1 from the hydrogen atom, so it becomes 8. At the same time, if you look at the other carbon, carbon has 3 covalent bonds, triple covalent bonds, not 3 covalent bonds, triple covalent bond. That means it is sharing 3 pairs of electrons. So यहाँ पे भी carbon पे पास हो गया 8 electrons. So both the carbons are stable. Both the hydrogens have 2 electrons. So both the hydrogens are also stable. These are known as covalent compounds. This is all we had done in the class today. I hope everybody has understood everything. And if you have any doubts, please do let me know and we will try to solve your doubts. And see you all tomorrow in the next class.